hold it. So it is a very simple experiment. It will not take much time. Just an introduction about the experiment I will be giving you, and subsequently you will be performing your experiment and as soon as possible, and you have to share your screen for your marks to be recorded accordingly. So today's experiment is design of Yagi-Uda antenna array to find the directivity and half power beamwidth from the radiation pattern. Why it is very similar to your previous experiment? Because I think most of you have learned about Yagi-Uda antenna array and might have seen in their home in older days. I mean, these Yagi-Uda antenna arrays were used to increase the gain, right? So you can see a simple dipole. So though the Yagi-Uda antenna array is not limited to these three elements, but it can be more than that. So I chose a very simplest of the Yagi-Uda antenna array, and here we will see that this particular antenna, the middle element, is the dipole antenna, which is center pair. The operation of which is exactly similar as we had done in our previous class. So what is the purpose of this Yagi-Uda antenna array? You can see another element in the front, one element in the front and one element at the back side. Okay, there may be more number of elements in the front and one more element in the back side. Okay, so what is the function of these elements? The back element, which is longer than the feed dipole, so this acts as a reflector. Okay, so the longer one acts as a reflector, and the one which is at the front of the original dipole antenna is generally same in length or shorter than the center fed dipole. So this acts as a director. So in effect, the directivity increases. Okay, so what we will do, simply we will find whatever parameter that we had found in the previous class. So I had shown you the experiment for dipole antenna operating at 1 gigahertz. So I chose to design a Yagi-Uda antenna array to design for operation at 1 gigahertz. The dimensions are like this. You will find how to choose the dimensions in any standard textbooks. Okay. Though there is no concrete formula of choosing the dimension, it is an optimization process. Okay. So you can choose the dimension as I have chosen over here, and you can see the the S11 characteristics, where the dipole resonates at Yagi-Uda antenna array resonates at 1 gigahertz. So what is most important and interesting is to see the far field. Okay, you will get similar kind of radiation pattern, a figure of 8 kind of radiation pattern, but what is different is your directivity. In H plane, we had omnidirectional radiation pattern in case of dipole antenna. So here also you can note one thing: in H plane we do not have omnidirectional radiation pattern, but we have a directional radiation pattern, right? And as this software does the calculation automatically for half power bandwidth, you can see for your design how much you are getting. And finally, you have to find the directivity. See, you can imagine in our previous case, the directivity was very small. But see over here, directivity has increased up to 5.6. Okay, so that is most important. Uh, so I would like to suggest everyone to refer to the manual and start your design process as soon as possible. Okay, and not only designing, you have to make sure that you have to get it marked by us. Pushpa madam,
Again.
Amit Sen has not joined. I told him, but still he has not joined.
Yes.
Okay, I will be telling him, madam, the student who will be showing after performing the experiment, you can mark, please mark their roll numbers, those who are showing. Okay.
Yes,
Okay. Okay, students. I hope.
अभी तक तो एक्सपेरिमेंट 1 एक्सपेरिमेंट 2 सारा का सारा वो तो नहीं दे रहे हैं. 8 एक्सपेरिमेंट 1 में 8 स्टूडेंट बाकी है. एक्सपेरिमेंट 2 में भी हुई है.
ठीक है, let them do. Ultimately, they will lose marks. Okay. Okay. Okay, students, start performing the experiments. You have to reproduce whatever is there in your manual. Try to understand. Okay. Somebody respond such that my instruction is loud and clear. Somebody please respond.
Yes, sir.
Okay, start performing the experiment.